the land opposite the bear, the concept of balance. Good evening, and welcome back. Tonight, we journey to the far end of the map, to a continent of wind and light, where ice stretches for thousands of miles, and the sun can linger for months. Antarctica, nearly twice the size of Australia, is a place of towering ice shelves, hidden mountain ranges, and a silence so complete it feels like a presence. Some call it forbidden not by law, but by distance, cold, and the sheer force of nature. What does the ice remember? Layered within it are ancient atmospheres and long winters, a chronicle of Earth written grain by grain. Radar detects the buried gamberts of mountains. Beneath the glaciers are hidden lakes, like Vostok, sealed in darkness. On the surface, meteorites wait in fields of blue ice. Along the coasts, penguin colonies and resilient seals survive on a knife edge. While at research stations, scientists from many nations study climate, life, and deep time. We will examine the fossil remnants of a greener Antarctica, the history of Gondwana, and the treaties that keep this continent dedicated to peace and science. We will also explore the myths and bold claims that suggest something older sleeps beneath the ice, separating evidence from speculation. As always, I'd like to know where you are listening from and what time it is. Settle in, breathe a little slower, and let the cold and the silence carry your thoughts away. Let us begin. Start with a globe from the ancient world. At its top is the realm of the Big Dipper, whose stars gave the North its name. The Antarctic simply meant the country opposite the bare Antarcticos. Long before any keel cut the pack ice, the South existed first as an argument. Greek philosophers imagined a balance in nature and in geography. If land dominates the North, a counterweight must exist below the equator. Aristotle taught of a spherical Earth. Eratosthenes measured its circumference with astonishing accuracy. Strabo and Ptolemy codified climate zones and described the inhabited North and the unknown South. The idea hardened into a premise. To keep the world stable, a great southern continent must exist. Roman writers adopted the Greek system, and medieval scholars preserved it. The world was mapped by belts. Cold at the extreme north, torrid at the equator, cold again at the far south. Between these were the temperate zones where humans could live. The far south remained a white space with a name. Terra Australis Incognita, the unknown southern land. For centuries, it was drawn large because no one could prove it was small. Cartographers called their art science and theatre. Where knowledge ended, imagination began. The fields of the south were filled with invented coastlines and confident captions. In the age of faith, the south also provoked arguments about the antipodes. Were there people on the other side of the world? And if so, could they be descendants of Adam when the ocean girdled the globe? The question braided theology with geography. Some thinkers insisted there could be no human realms hidden so far away. Yet, merchants brought cinnamon from islands beyond the common charts. Sailors returned with tales of birds that never touched land. Each fragment lifted a corner of the southern veil. Away from the Mediterranean, at sea, a very different archive of knowledge was being created. Polynesian navigators crossed ocean basins using star paths, wave patterns, cloud formations, and bird flight as their instruments. They settled the distant islands of the Pacific and reached the high latitudes of Aotearoa, New Zealand. Maori oral traditions speak of a mariner named Huriti Nora who sailed into an area of mist, dark waters, and white cliffs that moved. Later scholars read these lines as a poetic memory of icebergs and drifting ice. Whether a little journey or a fabulous warning, the tradition shows that the peoples of the Pacific imagined and perhaps touched a colder world to the south long before European charts caught up. By the Renaissance, the old premise returned with renewed force. Print multiplied maps, compasses improved, and caravels and naos extended horizons. Cosmographers in Venice, Lisbon, Dieppe, and Antwerp stitched travelers' reports into master charts. The result still placed a continent to the south because balance still seemed necessary. Gerard Mercator circled the bottom of his world with a vast southern land that embraced the unknown. Orance Finn offered a triangular Antarctica with bays and capes, meticulously named but never seen. The practice was honest in its own way. The map acknowledged where knowledge ended by drawing boldly. The South remained a theater. The logic of sailors from interspace to force, the more explorers found islands and straits in the Pacific, the more they believed a great southern continent must lie somewhere nearby. The Strait of Magellan implied a barrier. If the Atlantic ran into the Pacific through a narrow neck, land had to curve below it. Dutch ships, working the Roaring Forties, recorded seas that stretched unbroken for days. They called it the brave west wind. The ocean swelled, the sky lowered, and every instinct told the helmsman that a continent was not far beyond the horizon. The logic of sailors kept the unknown land large. Religion, commerce, and pride intertwined with this geography. Monarchs issued patents to discover and seize. Private consortia funded voyages in exchange for whales, blubber, and the chance to find a new spice coast. Scholars in the Republic of Letters exchanged notes about southern magnetism and the riddle of the compass that dipped when sailing south. Natural philosophers wondered if new constellations govern new climates. The Southern Cross rose over the decks and gave mariners a nightly proof that they had entered a different sky. Yet the land that would one day be named Antarctica remained a rumor, anchored by mathematics and tradition. Facts accumulated on the periphery. Al-Idrisi in the 12th century compiled a world survey that acknowledged ignorance south of the known zones. Portuguese and Spanish pilots recorded cold currents that flowed north like rivers. The Humboldt Current chilled the coast of South America, and its force spoke of mighty winds and an engine in the polar seas. Whalers found driftwood from trees that do not grow in Patagonia, and reasoned that rivers from some other shore had carried it. In each case, the evidence was circumstantial but compelling. The South existed not yet as a coastline, but as a force. The modern fascination with Antarctica begins here, in the interplay of reason and desire. The need for symmetry created the continent in the mind. Courage and curiosity kept it on the chart. By the late 18th century, this imagined land had become a challenge, not a picture. To test this premise, men had to sail into latitudes where summer holds a weak sun and winter erases the horizon. The next act was to turn Terra Australis incognito from a supposition into a landscape. Stepping across that threshold, the white continent would emerge not as a paradise, but as a sovereign world of ice, holding most of the planet's fresh water, larger than Europe, and nearly twice the size of Australia. A continent whose past life in warm ages and whose hidden chronicle in the ice would one day make it central to the story of Earth. Imagine a scriptorium where parchment smells of glue and lamp smoke. A cartographer scores a grid onto calfskin with a compass and stylus, then draws rim lines that flare out like starbursts across the oceans. Early world maps were not just pictures of coasts. They were arguments about how the Earth works. For many scholars, balance required a southern land mass to counter the known mass of Eurasia and Africa. The name Terra Australis incognita stood on the lower edge of knowledge, more a promise than a place. Classical learning beget this promise. Ptolemy's geography preserved a mathematical Earth with a grid of latitude and longitude. Medieval scholars copied his ideas into maps that blended scripture with geography. Where reports from sailors and merchants grew thin, invention took over the picture. Sea monsters rose from the white space to signal ignorance. The great southern land was drawn as a continuous edge because a blank on the page felt less honest than a clean sheet of paper. With the rise of oceanic empires, the white spot became a prize. Iberian crowns guarded the master charts, known as the Padan Reel, as if they were state secrets. These working charts were updated with soundings, currents, and new capes when pilots returned to Seville and Lisbon. In the north, the Dieppe school in France produced lavish maps in the 16th century that showed the great southern continent, richly named and entirely fictitious. Orance Finn published a heart-shaped world map in 1531 that wrapped a triangular southern land around the pole and labeled it recently discovered, but not yet entirely known. The cautious language masked a leap of faith. A few artifacts gained later fame far beyond their probable intention. The Piri-Reis map, drawn in 1513 by the Ottoman admiral, stitched together earlier Portuguese and perhaps Colombian sources. Its southern reach provoked the claim that it showed an ice-free Antarctica. Most historians read it differently. The coastline aligns more naturally with South America, stretching to far south and misinterpreted around an unknown archipelago at the continent's tip. Yet, the very persistence of the claim shows how the white spot at the edge of the world provoked bold interpretations. The instruments of navigation shaped what cartographers dared to draw. Sailors could find latitude with relative certainty, measuring the altitude of the sun or familiar stars with an astrolabe, the astronomical quadrant, and later the sextant. Longitude remained elusive until the marine chronometer in the 18th century allowed time to travel. Before that, long distances east-west on maps stretched and sagged. Coasts in higher latitudes wandered like loose threads. In the Southern Ocean, where storms obscured the sky and ice drifted like pale cliffs, a captain could not fix a precise position, which meant a cartographer could not fix the continent's edge either. Gerard Mercator revolutionized the craft with his famous projection in 1569. He sacrificed true area in favor of straight lines of constant compass, bearing a boon to pilots who plotted courses by direction. His spacious southern edge encouraged the long-standing habit of ringing the map with a continuous unknown land. Abraham Ortelius, who published the first modern atlas in 1570, followed suit with an elegant southern land that helped the map feel complete. Completeness was part of the art. Blank borders did not sell. Even where the south seemed to offer a concrete trace, the ocean answered with riddles. Ferdinand Magellan found a strait that bears his name in 1520, a narrow choke point between the tip of South America and a land he mistook for part of the Great South. Many supposed that a continental wall must curve away from this channel, which inflated the unknown land on maps for generations. Dutch ships later rumbled east with the westerlies and recorded vast stretches of unbroken sea. The sameness of the waves suggested a deep basin ringed by land beyond sight. The Great Voyage of Abel Tasman in the 17th century traced the edges of Tasmania and New Zealand, and then turned back when storm and the unknown caught up again. Glimmers of a shore fueled the idea of a larger whole lying just out of sight. Evidence also infiltrated the charts through natural history. Sailors brought back tales of cold currents that cut north along South America. The Humboldt Current, rich with life, chilled coasts otherwise warmed by latitude. Such energy implied a powerful engine in the high southern latitudes. Whalers reported on fields of drift ice and logs from distant shores caught in the pack, proof that rivers and winds were working far from any known coast. The stars themselves heralded a different world. The Southern Cross rose over unfamiliar seas. Magnetic compasses dipped and behaved poorly, a puzzle that Edmund Halley studied on his South Atlantic voyage around 1700, producing one of the first magnetic declination charts. The South Pole needles and mines equally. Car touches and marginal notes betray the psychology of the age. Cartographers often wrote that the southern land was placed to maintain symmetry, to conform to the winds and currents, or to uphold the philosophy of climatic zones. Some penciled in names of bays and nations that no traveler had met. The rhetoric of discovery preceded the fact of it. This did not imply fraud. It meant that maps were working documents that balanced fact, inference, and expectation. Fantasies and geography from blank to itinerary. At the bottom of the page, the imagination bore most of the load. The blank space also fueled speculation about old knowledge. Renaissance scholars hunted for ancient authorities who could confirm rumors of a southern world. They found none that described a real Antarctic shore. Yet, antiquarian projects, Islamic scholarship, and the reworking of classical geography lent weight to the belief that an Antipodes land must exist. Later readers projected modern desires onto early artifacts. A misinterpreted cape or a distorted island became in fertile minds a prehistoric survey of an ice-free pole. The distance between cautious inference and romantic assertion could be measured by the width of the map margin. As the printing press spread, so did the public appetite for the marvelous. Booksellers in Antwerp and Venice offered atlases that made armchair travel possible. The southern land became a stage for sea serpents, for speculative names of cities, for neat borders around the unknown. At the same time, working pilots demanded better shoreline detail for places they actually sailed. This tension led to a curious result. The known was strengthened by accuracy, while the unknown swelled with confidence. Nowhere did this paradox manifest as clearly as around the Antarctic Circle. By the mid-18th century, the science to test the great southern idea had finally matured. Sextants and reliable chronometers lessened the fog of longitude. Hulls were sturdier, provisions better packed, and naval powers financed true oceanic exploration, rather than raids and trading ventures disguised as discovery. The Royal Navy and other powers took aboard astronomers, naturalists, and artists. They expected measured skies, collected birds, and sketches of every shoreline, as well as claims and charts. The South shifted from a rumor to an itinerary. The cartographic history of Antarctica then begins with honest blank spots and necessary fictions. The maps that showed a broad white ring were less errors than scaffolding, erected while the world waited for ships that could survive the polar seas. Early charts caught a presentiment of the continent and held it until instruments and men could confirm or refute it. The last line of Terre Australis on a copper plate might have been a guess, but it kept the focus on the polar boundary. That attention would drive expeditions into latitudes where the sun stays low and the sea heaves like a living thing. Soon, the theatrical southern border on the page would transform into real capes, real islands, and a real barrier of ice that resisted every keel. The story shifts from the maps to the water. Sails fill, rigging creaks, and a wooden hull noses into a southern surf that smells of salt and snow. For centuries, Terre Australis was a promise on the edge of a page. In the 18th century, it became a route. The Crown and the academies sent mathematicians and mariners into the highest latitudes to test if the world's imagined counterweight was real land or a mirage born of symmetry. The prelude to discovery began with fragments. Mariners from Europe pushed further south along the Atlantic and Indian Oceans, and returned with reports that were precise in feeling and vague in location. They spoke of a line on the sea where the water suddenly chilled and a grey mist thickened, where bird life changed overnight, and where ice appeared like white cliffs drifting on a black plain. We know this boundary as the Antarctic Convergence, a belt of water where the cold polar seas dive beneath the warmer oceans. Old logs, written in cramped hands by poor light, already sensed the planetary engine before it had a name. There were other hints. In 1739, a French navigator glimpsed a scrap of land, ice-covered and storm-beaten, now called Bouvet Island, a lonely outpost in the path of the great circumpolar current. A few decades later, a Breton nobleman named Yves Joseph de Kerguelen believed he had found the edge of the southern continent. He returned to Europe with news of a discovery fit for a monarch. When a second expedition made landfall on the same shores in 1773, the truth was colder. The Island of Desolation, as his men named it, was no continent. It was a wind-battered archipelago with surf for music and penguins for citizens. The South still held its secret. Then came the most systematic test the age could mount. Britain sent James Cook, a surveyor with the patience of a mathematician, and the weather sense of a sailor, to the Southern Ocean with two sturdy ships and new instruments. In his cabin lay a copy of Harrison's marine chronometer, a timekeeping device that allowed longitude to be carried from Greenwich to the edges of the Earth. With it, Cook could fix position, not guess. His crews ate sauerkraut, wort, and citrus to prevent scurvy. On deck, he had artists and naturalists whose job it was to record as carefully as the sailors measured. If the southern continent existed, this armada of order would find it. In January 1773, Cook crossed the Antarctic Circle for the first time in recorded history. He described a world of ice islands, low clouds, and a sea that seemed to breathe through the mist. In subsequent seasons, he crossed the circle again and again, tacking through ice floes. pushing south until solid pack ice barred the way. At one point, he reached 71 south latitude, farther than any known sailor, and stared at an ice field so vast it felt like a continental shore. He turned back only when prudence overruled will. Cook completed a circumnavigation of the high southern latitudes and proved a devastating negative. If Terre Australis existed as a warm, fertile land, it lay behind a fortress of drift ice and endless storm. He wrote in his journal that the risk of penetrating further outweighed the hope of benefit. Yet, even in his disappointment, his notes offered a key. He charted the bands of currents and winds that today we call the Antarctic Circumpolar Current. Discovery of the continent 182. In Cook's wake, other nations pushed south. The final years of the 18th century and the first decades of the 19th century saw a steady advance of sealers and explorers into the newly discovered archipelagos. Ringing the tip of the Antarctic Peninsula, South Georgia became a base for sealing and later whaling. The South Sandwich Islands and the South Orkney Islands entered the registers of empire. In 1819, a merchant captain, William Smith, blown off course, sighted a chain of icy islands north of the peninsula. The South Shetland Islands soon filled with crude camps and flags of occasion. As men hunted seals to near extinction, along with the hides, the newcomers brought the craft of careful observation. They traced the outlines of bays, sounded anchorages, and learned where the sea froze early and where the ice broke late. Commerce, as it often did, paid for the first drafts of knowledge. Exploration followed profit, and curiosity followed both. In 1820, at least 3 expeditions reported sighting the Antarctic mainland within months of each other. On a January day, the Russian naval officer Fadi Fadivich Bellingshausen, commanding the sloops Vostok and Mirny, wrote of a high ice shore that was not a fleeting iceberg but a solid barrier, likely attached to the land. Days later, the Royal Navy's Edward Bransfield, sailing from the new sealing grounds, sketched mountains along the tip of what we now call the Trinity Peninsula. Later that year, the American sealer Nathaniel Palmer approached the same peninsula and saw a vast shore of ice and rocks where charts were blank. The world had imagined Terre Australis for 2 millennia. In 1820, mariners finally saw it. The language of ice glaciology and biology, even as the first outlines of the continent, were entered into logbooks. New kinds of knowledge were being gathered in the rigging. Naturalists noted how the pack ice formed pancake edges and how pressure buckled the floes into ridges that stretched for miles. They catalogued penguins by bill and call. Adley penguins, inhabiting colonies, defended pebble nests with comic seriousness. Emperor penguins, discovered a bit later, incubated their eggs on their feet through a winter unimaginable to those who hadn't felt it. Sealers learned the habits of leopard seals, which hunted in the shadow beneath the ice, and crab-eater seals, whose teeth were like strainers for krill rather than crabs. The South rapidly taught lessons to those who observed. The environment itself began to convert into a pattern book. Navigators learned to read the language of light. A pale glow in the distance meant ice blink, where the sun reflected off the pack ice even below the horizon. A grey arc over the water could signal open patches pollinias. Whales became guides. Where humpback whales fed, there was krill. And where there was krill, there were likely pollinias, recurrent areas of open water surrounded by ice. Storms came with little warning, and those coming from the west gained teeth as they raced along the path of the circumpolar current. Icebergs carried stories in their forms. Tabular bergs, calved from vast ice shelves, drifted like floating plains. Blue stripes meant old, compressed ice. Dirty stripes meant rock, picked up from a grounded ice shelf or coastal cliff and carried to sea by a moving glacier. A good captain learned to read these signs and keep his ship out of the grip of the crushing pack ice. The impulse to order what was seen led to the first coherent maps of the Antarctic edge. French, British, and American ships added capes and extremities to the charts with every season. James Weddell, a British sealer and explorer, pushed unusually far south in 1823 through a bay of clear water, and reached a new record, near $74 circa south latitude. He described seas so calm, they seemed unworthy of the latitude. Later mariners would find those waters choked with ice and name them the Weddell Sea in his honor. To the west, along the long finger of land, later known as the Antarctic Peninsula, mariners found straits and bays that eased passage when the ice was favorable. These were small openings in a harsh geography, but this was how men learned to move in a place as hostile as any on Earth. Science had already begun to build a framework around these experiences. Theories of glaciation, which grew out of European valleys, found their largest canvas on the southern continent. If alpine ice could grind granite to flour and leave moraines like bookends in a valley, what could a continental-sized ice sheet do? Cook's notes on currents and winds prompted a generation of natural philosophers to view the South, not as a static icebox, but as an engine in motion. Magnetic observations from the high southern voyages fueled early models of how the Earth's field changes with latitude and time. Every small advance struck back at the myth. The continent was no longer a point of equilibrium for the northern lands. It was a real geological body with its own mountains, its own rivers of ice, its own climates that influenced the fate of coasts thousands of miles away. Lessons of harsh survival. The human story in this phase was one of pure endurance. Ships entered waters where the margin for error was measured in hours. Scurvy was less common than before, due to better diet and faith in fresh food. Yet, cold and hypothermia took their toll. Hulls leaked where the ice pinched too hard. Rudders broke when bergy bit small pieces of icebergs came up beneath the heavy surf. Lighting a fire was deadly and rare, for no one wished to light one below deck in a tar-filled hold. Sleep came in snatches, and men learned to move on a deck that could jump from a heavy wave and ice over in an instant. All this labor served a sober purpose. The map had to be corrected. The world needed to know if the last unknown continent was truly there. The fantasies and geography of the past remained at the bottom of the page. The imagination bore most of the load. The blank space also fueled speculation about old knowledge. Renaissance scholars hunted for ancient authorities who could confirm rumors of a southern world. They found none that described a real Antarctic shore. Nevertheless, antiquarian projects, Islamic scholarship, and the reworking of classical geography lent weight to the belief that an Antipodes land must exist. Later readers projected modern desires onto early artifacts. A misinterpreted cape or a distorted island became in fertile minds a prehistoric survey of an ice-free pole. The distance between cautious inference and romantic assertion could be measured by the width of the map margin. As the printing press spread, so did the public appetite for the marvelous. Booksellers in Antwerp and Venice offered atlases that made armchair travel possible. The southern land became a stage for sea serpents, for speculative names of cities, for neat borders around the unknown. At the same time, working pilots demanded better shoreline detail for places where they actually sailed. This tension led to a curious result. The known was strengthened by accuracy, while the unknown swelled with confidence. Nowhere did this paradox manifest as clearly as around the Antarctic Circle. By the late 1820s, a new reality was established in the Southern Ocean. The blank spot on the map had boundaries. High land existed beneath a fortress of ice. There were coasts framed by mountain ranges and vast ice shelves that calved into the sea. With the roar of cannon, the Southern Ocean was not a trackless waste, but a system of winds and water that could be read and used. The southern continent did not answer an ancient dream of balance. It answered physics and weather. It could be visited, skirted, and measured, but not conquered. This recognition closed a century of conjecture and opened a century of contact. The next chapter would bring men onto the ice itself and begin to reveal what this continent was like in warmer times and what it might mean for the planet. First footprints. Davis, Ross, and Wilkes. The first steps of man on the Antarctic mainland were tentative and full of doubt. The records read like a series of small claims staked against a great silence. In February 1821, The American sealer John Davis noted in his journal that he had made landfall on a rocky beach, south of the new sealing grounds. His words are sparse and cautious. Later historians argued over the location and what counted as mainland versus a nearby island, or grounded floe. The claim remains disputed, which feels fitting for a coastline that hides behind weather and whiteout. What is certain is that, by the mid-19th century, sealers and explorers were landing on the islands and peninsulas on the northern fringe of the continent. They left behind boot prints, barrel staves, and piles of bones that told a harsher truth. The Southern Ocean was becoming a hunting ground as well as a frontier of science. Even as commercial crews worked the rookeries, the fleets of 3 nations charted the first long arcs of the Antarctic coastline. In 1840, the French captain Jules Dumont d'Urville pushed his ships through fields of pack ice and named a vivid section of coast Adley Land in honor of his wife. That same season, the United States exploring expedition led by Charles Wilkes sketched an intermittent line of ice, cliffs and rocky outcrops along what would later be named Wilkes Land. The following year, the British commander James Clark Ross pushed down a great bay now named in his honor, and discovered a sight so incredible that his logs read like astonishment. Towering before his nose was a perfectly straight wall of ice hundreds of feet high that stretched past the horizon. He named it the Great Ice Barrier. Today we know it as the Ross Ice Shelf. On a clear day, steam and smoke curled from a volcanic cone near his anchorage. Ross named the 2 volcanoes Erebus and Terror after his ships. Erebus still smolders above McMurdo Sound and reminds every visitor that the continent is as much alive as it is cold. Ross did more than name capes. He carried geomagnetic instruments and fixed lines of magnetic force on the sea and on shore to improve the world map of magnetism. In an era where the compass could deviate from truth with latitude and time, such work was vital. He also showed where a ship might be able to winter and where the ice would crush even the sturdiest hull. His charts became guideposts for future generations. For most of the 19th century, the people who set foot on the Antarctic shores were there for hides and blubber. The sealing boom that exploded in the South Shetland Islands collapsed as quickly as it arose. Hunters switched to elephant seals for their oil. Whales were necks. The Southern Ocean rewarded skill and punished haste. Crews learned the grammar of the ice. They watched the cracks of the tide and for the blue light that meant thin ice ahead. They anchored in obsidian water under the cover of grounded icebergs. They learned that a tabular iceberg could calve without warning and send a low wave across a bay that would lift a ship effortlessly, then cast it down. They also began to leave records that science could use: temperatures, winds, dates of freeze up and break up, notes on the animal colonies that rose and fell like frontier towns. The first confirmed landing that no one disputes occurred in 1895 when a Norwegian whaling vessel under the command of Henrik Bull reached Cape Adare at the tip of the Long Peninsula. Among the crew was an English-Norwegian man named Carsten Borchgrevink. He leaped ashore and collected fragments of rock with lichens clinging to them. This small bundle became a scientific fact of great import. Lichens are slow and stubborn. Their presence proved that life clung to the outer edges of the continent, even where wind and salt spray penetrate to the bone. Borchgrevink returned to Cape Adare a few years later, leading the Southern Cross expedition in 1899. He and his men built prefabricated huts of Norwegian timber on a shingle beach crowded with penguins. They brought Greenland sled dogs, the first on the continent, and learned to live through the polar night with blubber stoves and strict routines. They achieved the first successful wintering on the Antarctic mainland. Their meteorological records, their coastal surveys, and their proof that dogs and men could push inland with discipline and caution marked a threshold. Antarctica ceased to be a place ships merely touched and fled. It was a place where men could stay, observe, and plan deeper journeys. The scientific kitchen, the first bases in the same era. A pattern emerged that still defines Antarctic work. Expeditions blended national ambition with a scientific program. The Discovery Expedition 1901-1904 berthed a wooden bark in the safe waters of McMurdo Sound, and built huts on Ross Island. Robert Falcon Scott commanded the enterprise. With him sailed the physician and zoologist Edward Wilson and a young merchant marine officer, Ernest Shackleton. They were the first to use the steep glacial tongues and frozen straits of McMurdo as a route from sea level to the high polar plateau. The party traced the Farrar Glacier, mapped new coasts, and found an emperor penguin rookery whose life cycle defied all assumptions about survival. A German expedition led by Erich von Drygalski sailed the ship Gauss and became locked in the ice for nearly a year. Instead of failure, the forced stop became a field season. They sent up balloons to measure the winds. They surveyed a lonely volcanic hill they named Gaussberg, a black dot on a white plain. They gathered oceanographic data and proved that good science could be done when the ships could not move. A Scottish expedition led by William Spears Bruce worked on the South Orkney Islands 1902-1904, established a meteorological station on Laurie Island, and handed it over to Argentina. This base, now called Orcadas, became the oldest continually operating station in Antarctica. By this time, South Georgia in the subantarctic had transformed into a whaling engine. The Norwegian captain Carl Anton Larsen established a station at Grytviken in 1904. Within a few seasons, the island's sheltered bays were wreathed in steam from processing sheds and echoed with the clang of barrel hoops. This industry would soon profoundly undermine whale populations and provoke international regulation. It also built a series of ports and workshops that later explorers would rely on for repairs, coal resupply, and hiring men who knew the seas of the far south. These first landings and first winterings redrew the map of possibility. Men learned there were windows when the pack ice eased and safe harbors when the wind blew off the land. They learned where soft snow concealed crevices and how to read sastrugi-wind carved ridges that tell a traveler the prevailing weather direction. They learned that a sledge needed careful loading and that a dog team had to receive predictable rations if it was to pull in the savage cold. They learned that the human body could not carry enough calories to lay a route without regular food and fuel depots placed in advance. They learned that a tent could be a temple of order, where wet wool dried, maps stayed flat, and morale was held. The scientific achievements of these early shore parties were real and durable. Collections of rock and fossils, taken from Nanatics, ice-free peaks, and coastal capes, showed that the continent had once been warm and forested. Coal seams lay exposed in the transantarctic mountains. Glossopteris leaves Glossopteris, imprinted in stone, would later prove the existence of the prehistoric supercontinent that once linked Antarctica to distant lands. Meteorological records of the winter nights began to reveal the engine that drives the katabatic winds down the slopes and over the sea. Soundings and tide gauges refined the first sketches of the continental shelves and the ice front. Every speck of data pulled Antarctica out of myth and into geology and climatology. Above all, these first intentional steps on the ice established a method of operation that every subsequent expedition would hone. Build a base in a safe harbor, winter over with patience and discipline, scout the trails to the plateau, lay depots on the routes, travel in the spring, when the light returns and the temperature is still low enough to keep the snow firm, return before the pack ice closes. This is not romance, it is method. In the process, a new chapter opened, and with it, the era of grand journeys that would push toward the heart of the continent. The Race and Different Philosophies 1911, the race began with the spring light. Amundsen's team moved out in stages to lay depots along a new route that led from the Bay of Whales up a steep glacier he named after the geologist Axel Heiberg. The ascent to the plateau was quick, and the snow was cold and dry. The Norwegians traveled with a rhythm honed in the high Arctic. Skiers set a steady pace. The lead man measured distance with an odometer, and the sun was used as a landmark. The dogs pulled light sledges and were well fed. Where crevices crossed the route, the men probed them with poles, bridging them with speed and distributing weight. On a good day, the team could advance over 20 miles and still cut snow blocks and build a cozy, low snow wall for the night. Amundsen kept his party small. He selected 4 men to go with him for the final push. The sledge loads were balanced, the dogs still strong. At McMurdo, Scott's expedition also ventured inland to lay supply lines. The 1-ton depot, the crucial cache for the return, was placed slightly short of the intended latitude due to weather and the condition of the animals. It was a small alteration, but one with large consequences. Scott sent an early party, led by Apsley Cherry Garrett, to collect emperor penguin eggs for science. During the polar night, an effort that showed courage and dedication, but also drained energy and resources. When the journey to the pole began in earnest, the polar party set out with man-hauling power, a few surviving ponies, and the hope that the surface would firm up with the cold. The animals were shot as planned, and the loads redistributed. The men hauled sledges that weighed like a small car across the deep snow at altitude. The Beardmore Glacier, so majestic when discovered, proved to be a brutal staircase. Sastrugi cut at ankles and sledge runners. Crevices yawned where the sun struck. The top of the plateau sits at about 3,000 meters above sea level. The thin air, extreme dryness, and cold cause dehydration that can be masked by a lack of thirst. The rations, which looked sufficient on paper, proved insufficient for bodies working at the limit of human capacity. Amundsen reached the polar plateau ahead and in better condition. He found a route that avoided the worst broken ice and kept a strict pace. On December 14, 1911, 5 Norwegians stood at the place where the compass spins and the sun circles. Amundsen, Bjaaland, Hansen, Hassel, and Wisting planted a flag, took careful observations, and built a small tent with a message for Scott. They measured the position with solar sightings over 2 days to be sure of the mark. The angles of the theodolite, the recorded temperatures, and the neat biscuit tin completed a simple ceremony of precision. They turned home with dogs in good condition and a chain of depots at their back. Scott and his companions reached the pole on January 17, 1912. Their names are now carved into the memory of polar history. Scott, Edward Wilson, Henry Bowers, Lawrence Oates, and Edgar Evans. They found the tent, the flag, and the note. They found proof of their rivals' foresight and mastery. Wilson sketched. Scott wrote his diary with dignity and pain. They had lost by 34 days. They had also spent more energy getting there than their rations allowed for the return. The march back began across ground that was now psychologically heavier and physically more severe. The return was an accountant's ledger of loss. Evans, the strong seaman, sickened after a fall near the Beardmore Glacier and died near its foot. Oates, suffering from frostbitten feet and weakened by the long haul, walked out of the tent into a blizzard to avoid slowing his friends. "I am just going outside and maybe some time," he said. The 3 remaining men pushed south across the plateau and down onto the shelf toward their depots. The weather worsened more than any record had predicted. Temperatures fell below the average for that season. Winds intensified. The final camp stood less than 12 miles from the 1-ton depot, a cache that could have saved them had it been placed slightly further south, or if the weather had been a little kinder. When the search party found the tent months later, they discovered diaries and letters that became some of the most powerful documents in exploration literature. Within those pages, the British expedition left a legacy of science, as well as grief. The geological specimens, collected near the glacier, were found beside the bodies. Among them were plant fossils that confirmed the old idea of a warm ancient Antarctica, connected to other lands. The heroic age is science, the judgment of means. While the race for the geographic pole captured headlines, the heroic age was more than one goal. Jean-Baptiste Charcot charted and named territories along the Antarctic Peninsula with careful caution and ran a hospitable ship that became a floating school of science. Douglas Mawson in the Australian Antarctic expedition led a march along the coast hammered by the strongest winds measured on Earth. A tragic sledge march left him alone on the plateau. hauling a sledge through starvation and hallucinations for weeks, a survival that defies belief. Elsewhere, meteorologists learned how the katabatic winds form as cold, dense air falls from the interior toward the sea. Oceanographers measured the deep water that forms around the continent and sinks to ventilate the world ocean. Biologists studied penguin rookeries as barometers of sea ice and krill. The heroic age built a tower of knowledge on a foundation of courage. Much of the outcome of the polar race came down to the judgment of means. Dogs on snow versus men and ponies. Skiers versus boots. A camp that sat in a secure harbor beneath a smoking volcano versus a camp placed on the edge of a moving shelf. The decisions were not romantic. They were practical. They came down to questions of friction and distances, calories and the limits of muscle. Amundsen's genius lay in a ruthless dedication to what worked in the cold. Scott's greatness lay in a dedication to science and duty that inspired service beyond the self. The South judged without appeal. By the end of this chapter, the map showed a route from sea to sky over the Beardmore and another up the Axel Heiberg. A line of flags marked the meridian of human effort to $90 circ south latitude. The price was high, but the benefit was permanent. The polar plateau was no longer a rumor. It had a measured altitude, a surface of sastrugi that a skier could read, a climate that could kill in hours, and a significance that stretched far beyond flags and nationality. The story of conquest would yield to the story of survival and science. Shackleton would soon return to prove that leadership could save men from impossible odds. The fossils brought out of the interior would cement a revolution in geology. The continent would move from a stage of rivalry to a laboratory for the planet. The white continent does not reward haste. It keeps what it takes and yields only to those who study its grammar. After the flags at the pole, the story of Antarctica broadened into something deeper than records and rivalry. It became an exploration of endurance, improvisation, and a quiet accumulation of knowledge that would change our understanding of Earth itself. Let us begin with a ship trapped in the ice. In the austral summer of 1914, Ernest Shackleton sailed the stout three-masted Endurance into the Weddell Sea, with a plan as simple as it was audacious: to land a party on the coast near Vassal Bay, cross the continent via the pole, and emerge at the Ross Sea, where a support team would lay depots across the barrier. The sea closed before the attempt could begin. Pressure ridges rose like city walls. By January, the pack ice held them tight. By winter, the ship became a wooden island, sitting on a moving plain. Men built dog kennels, played soccer on the floes beneath a sky of ice crystals, and listened to the hull groan with every ice contraction. In October, the ice pressure broke her spine. In November, the Endurance went under, leaving behind a spill of crates, rigging, and dreams. And the men began a march that would become a legend. Shackleton called a halt on a small rise of drifting ice, a place they named Ocean Camp, and then another they named Patience Camp. He reduced weight with a captain's ruthlessness. The gold chronometer casing and the Bible were left behind. The banjo was kept, because song holds morale. The carpenter reinforced 3 lifeboats for the long open water journey that might come. When the ice broke up, when the floe finally broke up, the boats took to a sea choked with icebergs and framed by walls of green ice. After 7 days of rowing and bailing, they reached a scrap of rock and gravel called Elephant Island. It was the first solid land they had felt in 16 months, and it was not salvation. No ship would wander there. Shackleton chose 5 men for an ocean crossing that any pilot of the time would have called madness. He and Frank Worsley, Tom Green, Harry McNish, John Vincent, and Timothy McCarthy launched the James Caird, a 7-meter vessel, aiming it for South Georgia, far to the northeast. They navigated by glimpses of the sun through storm and snow. Worsley took noon sights with a sextant, while waves rushed past the small boat like mountains. They reached the wrong side of South Georgia, crossed a surf line that would have smashed a lesser vessel, and then Shackleton and Worsley crossed the uncharted spine of mountains and glaciers on foot from night until morning to reach the whaling station at Stromness. Months later, after repeated attempts through the sea ice, they returned with a Chilean tug and picked up every man from Elephant Island alive and brought them home. The continent defeated the plan. The men were not defeated by the continent. The echo of duty and science. This rescue is the most famous story of polar survival, but it is not solitary. Across the broad Ross Sea, the group laying depots to support Shackleton faced its own ordeal. Storm after storm tore their sails and tents. Scurvy and exhaustion drove the men to the brink. They laid the depots anyway, because duty demanded it and because faith in the other party required it. Though that party would never appear on their horizon, a small wooden cross in the snow above McMurdo Sound stands in memory of the cost of that faith. A reminder that survival in Antarctica is never guaranteed, and that courage sometimes keeps its own counsel. Survival taught lessons that would also serve science. The Belgians on the Belgica had learned some of them 2 decades earlier. Trapped in the ice in 18,981,899, they became the first to survive an Antarctic winter at sea. The long darkness brought a sadness that was physical. Men slept too much, avoided the light, and dreamed with their eyes open. The ship's doctor, Frederick Cook, urged the crew to eat fresh meat of seals and penguins to fight scurvy, a recipe that worked and kept lives from vanishing into the silence. They sawed a channel through the young ice with saws and picks in the spring to reach open water. Out of that harsh season came hundreds of pages of magnetic observations, meteorology, and the understanding that the polar night changes the mind as surely as the cold changes rope. The lessons would echo for every crew that came after. Elsewhere, the work of holding onto life became the basis for meticulous science. Douglas Mawson's Australasian Antarctic expedition built a base at Cape Denison in Commonwealth Bay, a location where the katabatic winds spill off the plateau with a force unmatched on any coast on Earth. Instruments recorded average wind speeds close to gale force for weeks, and gusts that bent nails and turned ropes into wire. Mawson's Eastern Sledge Party vanished into a crevasse after one of the men, and a sledge fell through a hidden fissure covered by a snow bridge. The 2 survivors turned back on a trek that seemed to tear hours from life with every step. Mawson's long traverse and the scientific laboratory. Then one man died of starvation and sickness, and the other was left alone with a sledge, a broken connection to the world, and a hunger that made language sparse. Mawson reached the Hotter Ghost weeks after the ship had sailed away. A small wintering party remained, kept the records, and made the next year productive. Out of this outpost came oceanography, cartography, and biology that are still of value. The book Mawson wrote later, with a title that speaks the truth of his year, is as much a document of weather as of will. Science at the turn of the century did not mean one discipline. It meant a long list of patient tasks. Meteorologists kept hourly records, missing neither dawn nor midnight. Magnetic observers measured the angle of the needle and the horizontal force again and again. Because tiny deviations matter over the course of years. Ice observers logged the dates when the bays closed and when the first black water reappeared. Oceanographers took soundings and lowered bottles to collect water at depth, measuring temperature and salt content. These lines of numbers, stretched across seasons, created the first sketch of a system. The data showed that dense cold water forms around the continent and sinks into the abyss as Antarctic bottom water, which then ventilates the world's ocean. They showed that the winds falling from the plateau carry immense energy into the coastal seas and help create the polynuous open basins that fuel food chains and ventilate the ocean. They showed that the ice front breathes with the passage of the year, and that ice shelves calve along lines that can be mapped like fault lines on land. Penguin eggs and the geological revolution. Biology found treasures that started small. Apsley Cherry Garrett, the young officer with Scott, joined to comrades in the dark winter of 1911 on a trek that defies belief. Their goal was to collect emperor penguin eggs for embryological research, which a new generation of scientists believed might unlock keys to avian evolution. The three men hauled a sledge across pressure ice in the coldest weeks of the year, and climbed to a rookery located beneath a volcanic cape, while the wind tried to tear the clothes from their bodies. Eggs broke from sudden drops until they found a few they could salvage. They returned with frostbitten faces and a box of ivory that would travel to London. The science they hoped to unlock proved less conclusive than they believed. Nevertheless, the journey itself stands as a measure of dedication. Their accompanying book stands today as a testament to what curiosity will do when armed with method and fellowship. Geology used the sledge for a very different purpose, where the ice receded from peaks and ridges called nanatics. Parties chipped fossils from slate and sandstone. The glossopteris leaves that Scotsmen carried on their last trek were among these slabs of evidence. Flat tongues of rock marked with fern-like leaves and thick stem forms told of cold, swampy forests that pushed through the warm winds of a long summer sun. When such specimens were found in India, South Africa, Australia, and Antarctica, the idea of a supercontinent transitioned from speculation to theory. Gondwana had existed. The lands of the Antipodes had been neighbors. Antarctica had once sat in different latitudes, beneath forests and rivers, then slowly migrated to its current location and frozen over. The cold continent was a time machine. The tools that made survival possible also pushed observation forward. The Nansen cooker fed men with less fuel, using steam to simmer a second pot sitting above the first. This meant longer journeys or more time on a ridge to sketch and measure. Light sledges, carefully worked by hands that knew wood, conserved energy over hundreds of miles. Dog harnesses, perfected in Greenland, kept teams from tangling when a crevasse opened. Long skis distributed weight and turned a death trap into a passable snow bridge. Even clothing was a kind of tool. Reindeer fur, which shed rime ice to the outside, proved warmer than tightly woven cloth that trapped moisture. The best kit was not always the newest. It was the kit that was proven by men who lived the cold as a daily job. By the 1920s, a new tool changed the scale of the map. Aircraft came to the south. Sir Hubert Wilkins and Carl Ben Ilsen made the first mechanical flight over the Antarctic Peninsula region in 1928, tracing a coastline that would have taken sledge parties weeks to sketch. That same season, Richard E. Byrd, leading a large American expedition, established a radio-equipped base at the Bay of Whales and used ski planes to expand scouting over the Ross Ice Shelf, and then flew over the geographical South Pole in 1929. The view from height revealed patterns invisible from the surface. The long tongue of a glacier, the shear zones and flow lines on an ice shelf, the ridges of blue ice where wind scoured the snow from a buried hill. All could be seen, photographed, and mapped. Planes could not chip into a fossil bed or measure thickness with a drill, but they could direct the slow feet of science to places where time would be best spent. Permanent stations expanded the observation from years to decades. The Orcada station on the South Orkneys, founded by the Scottish Party and ceded to Argentina in 1904, kept daily weather records that would later allow climatologists to see trends, not just episodes. On the other side of the continent, small huts at Cape Adare, McMurdo Sound, and along the peninsula gave biologists places to return to colonies and count. Penguin colonies rise and fall with the sea ice and the pulse of krill. Long series of counts can reveal what a single season might hide. In the same way, repeated measurements of sea ice extent and ice shelf fronts cross the threshold from anecdote to climatology. When the floe finally broke up, the boats took to a sea choked with icebergs and framed by walls of green ice. After 7 days of rowing and bailing, they reached a scrap of rock and gravel called Elephant Island. It was the first solid land they had felt in 16 months, and it was not salvation. No ship would wander there. Shackleton chose 5 men for an ocean crossing that any pilot of the time would have called madness. He and Frank Worsley, Tom Green, Harry McNish, John Vincent, and Timothy McCarthy launched the James Caird, a 7-meter vessel, aiming it for South Georgia, far to the northeast. They navigated by glimpses of the sun through storm and snow. Worsley took noon sights with a sextant, while waves rushed past the small boat like mountains. They reached the wrong side of South Georgia, crossed a surf line that would have smashed a lesser vessel, and then Shackleton and Worsley crossed the uncharted spine of mountains and glaciers on foot from night until morning to reach the whaling station at Stromness. Months later, after repeated attempts through the sea ice, they returned with a Chilean tug and picked up every man from Elephant Island alive and brought them home. The continent defeated the plan. The men were not defeated by the continent. Preserving memory, Hurley and the end of romance. Another story from this era answers the charge that the South is merely a stage for catastrophe. In 1912, the Australian Frank Hurley hauled a heavy camera through storm and frost and took pictures that are both art and document. When the Endurance groaned and twisted in the grip of the weather ice, Hurley climbed the mast and fixed glass plates that captured the ship, caught beneath an arch of stars. When the ship sank, he dove into the icy water to salvage the negatives. He dried them in a sealed blubber-heated tent and created an archive that would teach generations what the Weddell Sea looks like when it decides to hold a ship. In the small acts of care that preserve memory, science and history keep each other alive. The heroic age concludes not with a flourish, but with a quiet change of method. What began as a contest ended as a collaboration between patience and observation. The continent taught every visitor that survival is a system. It requires discipline in small things, respect for the weather, and a willingness to place knowledge above pride. In return, Antarctica offered an archive of facts. It gave us the slow pulse of the world's ocean, the proof of a vanished supercontinent, the first climbing trails to the polar plateau, and a measure of what cold and time can do to rock, ice, and life. The next frame of history would expand this work again, from brave sledge parties to nations bound by treaty and scientific programs that study the planet. By studying the pole, over the decades, the public memory of Operation High Jump diverged into two paths. Documentary records show a massive, peacetime polar exercise that charted coastlines, trained crews, and identified weaknesses in equipment. Byrd told a Chilean newspaper of the strategic lesson any airman could see in an age of long-range bombers. The shortest routes between continents might pass over the poles, and this fact would change defense planning for every nation that could fly far and fast. Conspiracy literature, by contrast, turned the abrupt seasonal departure into a confession of defeat and the air route interview into a warning of unknown enemies made of ice. The gap between these stories is filled by a familiar human ingredient: the desire for drama where procedure is the truth. Even while High Jump was underway, other nations were making plans that would shape modern Antarctica. Britain continued its small network of scientific stations in the peninsula region and, in time, converted Operation Tabarin into permanent civilian research. Argentina and Chile placed their own bases and developed schools and families around them. One Argentine mother gave birth at Esperanza Station Esperanza to stake a claim with an axe. As ordinary as it was political, the Soviet Union would soon send expeditions that would traverse the continent and establish inland stations on the high polar plateau. Airdrops and tractor trains replaced dog teams for heavy work. In this crowded history, Antarctica transformed from a hard-to-reach destination into a field program under many flags. The stories of war in Antarctica are thus twofold. There is the record of real activity, and there is the layering of rumor that speaks to deeper human patterns. A blank map is an invitation. A remote coast suggests a sanctuary. When evidence is sparse, imagination is a generous partner. What remains undisputed is how these years set the stage for a new political idea. If war taught anything, it was the price of competition without limits. The sheer scale of High Jump and the parallel efforts of other nations clarified one fact: no single nation could claim the ice continent alone without provoking conflict. The next chapter would answer this fact with a treaty that turned a strategic boundary into a shared laboratory. Before that pact could be written, nations had to learn each other's methods on the ice and acknowledge that the weather is the only true master south of the circle. From air surveys and winter huts grew a fragile model of cooperation that endures. The International Geophysical Year Science as Catalyst. The world had just emerged from a decade of global conflict when a new experiment took shape at the bottom of the map. Instead of soldiers with rifles came builders with theodolites, radio sets, and cooks who learned to bake bread when the air itself felt made of ice. The International Geophysical Year IG, Международный geofizический год, MGG of 1957 and 1958, was the turning point. 12 nations organized the largest collaborative scientific campaign to date. They ringed the continent with stations and pushed inland to the very top of the pole. The US Navy carved a base out of the ice at the geographical South Pole and named it Amundsen Scott. The Soviet Union opened Mirny on the coast and Vostok deep in the interior, where the winter air can drop below -$70, circa $C. Britain, France, Japan, Norway, New Zealand, Australia, Argentina, Chile, Belgium, and South Africa added their own hard-won beachheads. Meteorologists launched balloons into the violet sky. Seismologists listened to the planet's footsteps in the bedrock. Glaciologists began the long discipline of drilling ancient ice to read the air of earlier worlds. For the first time, Antarctica felt less like a prize and more like a laboratory. The momentum of this shared year carried into diplomacy. On December 1, 1959, the same dozen nations signed the Antarctic Treaty, Dogovor of Antarctic in Washington. It took effect in 1961 and quietly changed the grammar of geopolitics. Peace. Antarctica would be used only for peaceful purposes. Military personnel could support science, but there would be no bases or weapons. Prohibitions. Nuclear explosions and the disposal of radioactive waste were banned. Science. Freedom of scientific investigation was guaranteed, and observations and results had to be exchanged. Inspection. Inspectors from any treaty member nation could arrive without notice and visit any station, or ship to sea for themselves. This last provision mattered. On a continent where rumor outraces the mail ship, inspection turned suspicion into a checklist. Article If held the most subtle balance. It shelved the question of sovereignty without erasing it. Nations that claimed sectors of ice did not have to abandon their claims, but no new claims could be made, and no existing claim could increase. The treaty froze the cartography of competing triangles and replaced it with a circle of cooperation. Real cooperation begins in the huts and workshops, not the treaty rooms. The stations built during the IG became year-round communities. At McMurdo Sound, the Americans ran a small city with a harbor cut through the sea ice each summer to receive cargo. Across the Sound, the New Zealanders built Scott Base and kept precise watch on the same winds and tides. Far to the east, the Australians made Casey and Mawson wind-hardened outposts and turned the fable of Commonwealth Bay into a weather and oceanography program that never sleeps. Argentina kept Orcadas and Esperanza where families were raised. Chile built its own chain of bases along the peninsula and held weddings and schools. The Soviet Union pushed deep inland to build Vostok on the highest and coldest of the plateaus. Many of these stations started as national ventures and transformed into shared logistics and common science. The Council of Managers of National Antarctic Programs (COMNAP), Soviet Upravlyaющих Nationalными Antarktическими Программами, was formed to share spares, flights, fuel, and advice. One nation's aircraft might land on a blue ice runway, maintained by another, and carry a field team from a third to a remote camp. The daily work of cooperation turned the grand language of the treaty into a worked habit. Governance expanded as experience grew. The treaty parties created a standing forum, the Antarctic Treaty Consultative Meeting ATC, Konsultatywno Sowieszenie po Dogovoru Antarctic, where delegations gather annually to review science, logistics, and environmental protection. Inspectors carry clipboards into machine shops and garbage rooms, and look under fuel lines for stains that tell a quiet story. The reports are public documents. In a landscape where a spill can spread for miles beneath the snow, or a careless fire can erase a decade of painstaking work, such openness is a form of safety. The habit of data exchange is a sibling to this habit. Meteorological observations feed into global networks. Satellite images of sea ice are available to any scientist who asks. A researcher from one nation can work at another station on a simple memorandum. In this field, the passport matters less than the plan. The International Geophysical Year Science as Catalyst. The world had just emerged from a decade of global conflict when a new experiment took shape at the bottom of the map. Instead of soldiers with rifles came builders with theodolites, radio sets, and cooks who learned to bake bread when the air itself felt made of ice. The International Geophysical Year IG, Международный geofizический год, MGG, of 1957 and 1958, was the turning point. 12 nations organized the largest collaborative scientific campaign to date. They ringed the continent with stations and pushed inland to the very top of the pole. The US Navy carved a base out of the ice at the geographical South Pole and named it Amundsen Scott. The Soviet Union opened Mirny on the coast and Vostok deep in the interior, where the winter air can drop below -$70, circa $C. Britain, France, Japan, Norway, New Zealand, Australia, Argentina, Chile, Belgium, and South Africa added their own hard-won beachheads. Meteorologists launched balloons into the violet sky. Seismologists listened to the planet's footsteps in the bedrock. Glaciologists began the long discipline of drilling ancient ice to read the air of earlier worlds. For the first time, Antarctica felt less like a prize and more like a laboratory. The momentum of this shared year carried into diplomacy. On December 1, 1959, the same dozen nations signed the Antarctic Treaty, Dogovor of Antarctic in Washington. It took effect in 1961 and quietly changed the grammar of geopolitics. Peace. Antarctica would be used only for peaceful purposes. Military personnel could support science, but there would be no bases or weapons. Prohibitions, nuclear explosions, and the disposal of radioactive waste were banned. Science. Freedom of scientific investigation was guaranteed, and observations and results had to be exchanged. Inspection. Inspectors from any treaty member nation could arrive without notice and visit any station, or ship to sea for themselves. This last provision mattered. On a continent where rumor outtraces the mail ship, inspection turned suspicion into a checklist. Article if held the most subtle balance. It shelved the question of sovereignty without erasing it. Nations that claimed sectors of ice did not have to abandon their claims, but no new claims could be made, and no existing claim could increase. The treaty froze the cartography of competing triangles and replaced it with a circle of cooperation. Real cooperation begins in the huts and workshops, not the treaty rooms. The stations built during the IG became year-round communities. At McMurdo Sound, the Americans ran a small city with a harbor cut through the sea ice each summer to receive cargo. Across the Sound, the New Zealanders built Scott Base and kept precise watch on the same winds and tides. Far to the east, the Australians made Casey and Mawson wind-hardened outposts and turned the fable of Commonwealth Bay into a weather and oceanography program that never sleeps. Argentina kept Orcadas and Esperanza where families were raised. Chile built its own chain of bases along the peninsula and held weddings and schools. The Soviet Union pushed deep inland to build Vostok on the highest and coldest of the plateaus. Many of these stations started as national ventures and transformed into shared logistics and common science. The Council of Managers of National Antarctic Programs (COMNAP), Soviet Upravlyaющих Nationalными Antarktическими Программами, was formed to share spares, flights, fuel, and advice. One nation's aircraft might land on a blue ice runway, maintained by another, and carry a field team from a third to a remote camp. The daily work of cooperation turned the grand language of the treaty into a worked habit. Governance expanded as experience grew. The treaty parties created a standing forum, the Antarctic Treaty Consultative Meeting (ATC), konsultatywno sowieszenie po dogoworu. Antarctic, where delegations gather annually to review science, logistics, and environmental protection. Inspectors carry clipboards into machine shops and garbage rooms, and look under fuel lines for stains that tell a quiet story. The reports are public documents. In a landscape where a spill can spread for miles beneath the snow, or a careless fire can erase a decade of painstaking work, such openness is a form of safety. The habit of data exchange is a sibling to this habit. Meteorological observations feed into global networks. Satellite images of sea ice are available to any scientist who asks. A researcher from one nation can work at another station on a simple memorandum. In this field, the passport matters less than the plan. Challenges and inevitability. Modernity, not all tensions have dissolved in the cold. Overlapping territorial claims still exist on the peninsula and in parts of East Antarctica, even though they have been shelved. Some nations emphasize presence by building new stations or lengthening runways, and others worry about how to distinguish science from strategy when antennas rise and air traffic grows. Tourism has increased as ships became safer, and the demand for the far south became a quiet feature of the travel economy. The treaty parties have responded with guidelines for landings and rules that limit the number of people ashore at any one time. The system bends under new pressure and tries not to break. It helps that Antarctica still punishes pretense. Weather does not negotiate. Ice does not recognize a flag. A plan that ignores either will fail, regardless of who signs the permits. The longer arc tells a simple story. The continent that could have provoked conflict became a school of patience. The International Geophysical Year taught that shared hardship can make neighbors out of rivals. The treaty cemented that lesson in law and kept the truce credible through inspection and open record exchange. The environmental protocol shifted the moral center from conquest to care. In the process, Antarctica revealed its deeper value. It is a climate archive and an ocean valve, a clean laboratory for astronomy at the South Pole, a nursery for penguins and seals, and a testing ground for how nations can govern a common good. On this stage, the practical work continues. Snow is shoveled from doorways. Fuel lines are checked for freeze resistance. Radios crackle in the dark hours. Outside, the aurora folds and unfolds in a green curtain, while inside, a student calibrates an instrument that will send a trail of numbers into the world's shared knowledge. Let us start with a hand wiping snow from a dark rock on a ridge that overlooks an endless white plain. The rock is not common rock. It holds the impression of a veined leaf, fine as thread. It is Glossopteris glossopteris, a seed fern that spread across the southern supercontinent in the Permian period, more than 250 million years ago. This leaf has been found in Antarctica, India, South Africa, and Australia. The match is so precise it reads like a passport stamp from a time when these lands were connected. The continent we call Antarctica was once the green part of Gondwana, stitched with Africa, Australia, and India, crossed by rivers, edged by swamps, and warmed by a sun that rose low but long in the summer days. The ice hides this history well, but it has not erased it. High in the Transantarctic Mountains, the glacier recedes season by season from lunatics, the bare black peaks that punch through the whiteness. There, geologists have exposed pages of deep past. Coal seams lie exposed on the mountain slopes, a startling sight in the coldest place on Earth. Coal is concentrated plant life. It means that forests stood here and fell here. Scott's party on the return from the pole carried sacks of such rock, with fossilized leaves impressed within them. These specimens, later studied in the quiet of a museum, helped prove that Antarctica was once forested and that continents can drift, like slow rafts, across the deep mantle sea. The forests were not like the ones we know today. They were dominated by glossopterids and other seed ferns, relatives of conifers, and leaves similar to ginkgo. In the high southern latitudes, the trees grew during months of dim winter light and months of near continuous day, leaving tree rings that are wide and then narrow in patterns that record the strange seasons. in the region of the Beardmore Glacier and near the Shackleton Glacier. Paleobotanists have mapped whole stands of Permian trees, preserved where they grew. Some trunks are still rooted, petrified, mineral-rich water having replaced the tissue cell by cell. In recent years, teams have found fossilized stumps and logs so fresh in appearance that you can see the texture of the wood beneath a thin crust of ice. The rings inside these stumps show bursts and pauses that tell a story of adaptation to polar light. Long before the ice took hold of the land, the lost world of Antarctica did not end with plants. The continent has yielded bones and teeth that populate a roster of ancient animals. On Mount Kirkpatrick above the Beardmore, field parties found the bones of a large predatory dinosaur with a crest of bone. Above its skull Cryolophosaurus, dating to the early Jurassic, about 180 million years ago. Nearby were found the bones of early sauropodomorphs, long-necked cousins of the giants, that later roamed warmer lands. On the islands off the Antarctic Peninsula, especially Seymour Island in the north, layers from the late Cretaceous and early Cenozoic hold the remains of marine reptiles, like mosasaurs and plesiosaurs. Alongside sharks and ammonites, they're spiraled cephalopods that plied the last great warm seas of the age of dinosaurs. From the same islands come the bones of giant penguins, birds the size of a man that swam in fish-rich waters when the climate was as mild as a modern temperate coast. Other fossils tell of a chapter that more directly united the continents. In the Triassic rocks of the Transantarctic Mountains, scientists found the bones of Lystrosaurus, a squat, beak-tusked herbivore that lived like a pig and grazed like a goat. Its fossils occur in Antarctica, India, and South Africa. The match is not only in form, but in age and the sediments in which the bones lie. Taken together, these finds gave Alfred Wegener and the geologists who followed him the comparative evidence they needed. Continents drifted. What is now the cold tail of the Earth was once positioned closer to the warm center, and the living things of these lands wandered across plains, where the ocean now lies beneath the ice. The retreat of the forest and the formation of ice, the climatic history surrounding these fossils, is no less dramatic than the bones and leaves themselves. For most of the Mesozoic era, Antarctica was warmer and supported forests even at high latitudes. Then the plates began to move. Australia began to pull away from East Antarctica, and the Tasmanian Gateway opened, changing how currents move between the Pacific and Southern Oceans. Later, the Drake Passage widened between the tip of South America and the Antarctic Peninsula. These openings allowed a continuous river of cold water to surround the pole, the Antarctic Circumpolar Current. This current is the strongest on Earth. It isolates the continent, locks the cold air in place, and soon helped the first great ice sheets to grow. By the Oligocene, permanent ice formed on Antarctica. The forests retreated, and the coal seams froze. Since then, the ice would grow and recede with the long beat of the climate. But the continent itself changed from green to white. Even within this long coldness, there were warm pulses. Sediment cores taken from the Amundsen Sea shelf and the edges of the peninsula contain pollen, an ancient DNA that hint at tundra vegetation in some coastal pockets in the mid to late Holocene. Other cores from older layers show that in the mid-Cretaceous, about 90 million years ago, a tropical rainforest grew near what would be a high southern latitude, with roots and soil microbes preserved in the chemistry of the mud. These snapshots do not contradict the great turn to ice. They add texture. Antarctica's climate has swung in a long arc, and the fossils are milestones in that movement. The living archive extends into the ocean. Shells and microfossils from the continental shelf show when the ice advanced over the seafloor, and when it retreated. Dropstone solitary boulders that fall from melting icebergs and settle in fine marine mud mark the paths of iceberg drift across past seas. Foraminifera, tiny shelled organisms, carry the oxygen isotope ratios in their shells that fix the temperature of the seawater in which they lived. Cores containing these microfossils allow scientists to draw curves of heat and cold that correspond to the growth and decay of the Great Ice Sheet. The correspondence between the terrestrial fossils and the marine record is the key reason We can say with certainty that the white world we see today grew from a greener world, and that the change was caused by plate tectonics and the new isolation of the pole within a ring of water and wind. Antarctica tells another story through its birds. Penguins evolved in the south when the climate was warmer and the seas were open year-round. Fossils from Seymour Island show that early penguins were both diverse and large, with forms that filled different niches along coasts that looked nothing like the modern ice edge. Over time, penguins adapted to colder water and to life along the expanding ice front. Their lifelines record the tightening grip of winter in their bones and beaks, just as the trees recorded earlier seasons in their rings. To expose a fossil layer on that island is like laying out a family album for a lineage that still waddles past visitors' boots at the edge of the modern ice sheet. Some of the most eloquent evidence of a warm Antarctica comes not from bones or trunks, but from the texture of the earth itself. Glacial polish and striations on the bedrock speak of ice flow directions and long ice processing, but beneath that polish on the peaks and ridges are weathered surfaces and ancient soils that formed before the ice spread over them. In the McMurdo Dry Valleys, the largest ice-free area on the continent, permafrost holds salts and microbes that persist year after year without liquid water. Yet, nearby buried soils carry the chemistry of older climates that were wetter and supported a thin film of life. The contrast between the present and the past is stark and sobering. A planet can swing from forests to sterile cold over the time of plate movements and slow shifts in currents. Antarctica also enriches the story of mass extinction and recovery. In rocks of Permian and Triassic age, teams have traced the ecological changes that followed the Great Dying at the end of the Permian period, when most marine species and many land species vanished. The plant record shows a transition from glassopto-dominated swamps to floras that include seed ferns and conifers of new species. The animal fossils show the rise of the hardy Lystrosaurus after the catastrophe, a survivor that spread across southern Pangaea and left skeletons where glaciers now flow. To stand in that cold wind with such bones in hand is to hold a chapter of resilience, written under a different sun. All these findings rely on meticulous field work made possible by short summer seasons and the logistics that now ring the continent. Helicopters carry teams to ridges where rock crops out for a few weeks. Sledges carry plaster and jackets for fragile fossils that would break if handled too roughly. From the cold rock, saw blades whine beneath gloved hands, while the sun circles the sky without setting. Samples travel by icebreaker and aircraft to laboratories where microscopes and mass spectrometers extract more secrets from each layer than an early age could have imagined. In this way, the white continent becomes a library. Its shelves are the rock ledges, and its pages are leaves flattened and bones half freed from the shale. The catalogue grows every season. The cumulative picture is not merely an elegy for a lost Eden. It is a precise record of a continent that has lived many lives. Warm swamps full of seed ferns and coal, river plains filled with dinosaurs beneath a long summer sun, marine reptiles in wide bays, giant penguins along forested coasts. Then the slow turn when the passages opened. The current began to circle, and the planet's climate turned around the pole. The ice we see today is not a mask laid upon a single face. It is the latest guise of a land that has changed in accordance with the Earth's deep rhythms. The clearest library of Earth's history is not bound in leather. It rises silently across the white wilderness and keeps its pages pressed into blue ice. Snow falls, air is locked in, and the year is sealed. The next year, it happens again. The voice of the past ice cores and atmosphere, layer by layer. The ice sheet builds a ledger of wind, dust, ash, salt, and the breath of living things. When scientists drill a thin core from this archive and raise it to the light, they hold a timeline that stretches far beyond written memory. Let us start with the bubbles. Every speck of ancient air is a sealed sample of the atmosphere. In deep cores from Vostok, Talos Dome, and Dome Fuji, and the famous Dome Sea core, researchers have measured the rise and fall of carbon dioxide, $, text go to $. and methane over hundreds of thousands of years. The pattern is not accidental. Temperature and greenhouse gases move together in the rhythm of glacial and interglacial periods, set by the slow changes in the Earth's orbit and tilt. At Dome C, the record stretches back about 800,000 years. In cold periods, $, to dollar, is at about $180, TEXT ppm. In warm intervals, it rises toward $280, TEXT ppm. These numbers repeat like stanzas. We are currently above $400, TEXT ppm, a value the ancient bubbles never reach. The reason makes the comparison clear. The past speaks, and the difference is striking. Isotopes speak of temperature. A water molecule can carry a heavier form of oxygen and a heavier form of hydrogen. How much of these enters the snowfall depends on the storm's temperature and the moisture's path through the atmosphere. By measuring the ratios in each layer, glaciologists draw a curve of heat and cold. Dust speaks of distance. In cold, dry times, the great southern deserts and Patagonian plains loft fine minerals into the air, which settle over Antarctica. In warm, wet times, the dust vanishes. See salt-marked storms and sea ice. Sulfates and volcanic glass mark eruptions. The Vostok ice has chemical spikes that correspond to great volcanoes in distant places. Tambora in the early 19th century, with its year without a summer. Krakatoa in the late 19th century, are known giants from earlier millennia that shook the sky and sea, and left a thin grey line in the ice above the South Pole. Not all signals come from above. The ice itself flows, and where it passes over bedrock, it can entrain tiny crystals and traces of metals that hint at the continent below. Radar, towed on sledges and aircraft, penetrates the ice sheet and returns the echo of the buried land. From these surveys, a hidden world emerged. The Gamburtsev Mountains, a rugged range the size of the Alps, sit buried beneath the center of East Antarctica. Vast valleys and plateaus, carved long before the ice came, are now locked in darkness. Beneath the ice lie lakes that have not seen daylight for perhaps a million years. Lake Vostok, the largest, a body of fresh water, bigger than many known lakes in the world, sealed beneath almost $4,000 Texan dollar of ice. The water is under pressure and barely moves, warmed by the Earth's heat and insulated by the ice above. Near Vostok, sensors detected a strong magnetic anomaly. The likely answer is unusual geology. Two others. It seemed like a key to something stranger. In science, the richest history is almost always the one that can be tested. Teams have drilled shallow lakes in the west with sterile tools and found life. In Lake Willans, they brought up water and mud that harbored microbes, feeding on rock and breathing chemistry in complete darkness. Life can thrive in isolation without sunlight, provided there is energy and time. The ice sheet also fixes the history of our star. Solar storms shower Earth with particles that collide with the upper atmosphere and create rare isotopes like beryllium-10 and chlorine-36. They appear as faint peaks in the snow record during periods of high solar activity, or when the Earth's magnetic shield weakens. The ice is thus a celestial diary. It also carries the whisper of the cosmos. Each year, micrometeorites dust the planet. In Antarctica, many of these tiny visitors are locked in the ice, and then, where the wind scours the surface into blue ice fields, they weather out and collect. This is why search teams on snowmobiles can find meteorites by the hundreds along the flanks of the transantarctic mountains. Among them are rocks from Mars and from the Moon, ancient fragments that fell long ago and were preserved by the cold and the wind. In the Allen Hills, a team in the 1980s found a Martian rock with mineral features that ignited a famous debate about possible fossil life. The debate sharpened the methods, which is the best outcome such debates can have, and the blue ice still yields new stones every summer. Continuous inquiry, shifting cycles, and new questions. There are deeper questions the ice may answer, and scientists are working on them now. The goal is to retrieve ice that is older than 1 million years. old enough to capture a shift in the tempo of the great glacial cycles. Before that threshold, climate swings followed a shorter rhythm. After it, the cycle stretched into longer intervals. The cause is still debated. Changes in ice sheet dynamics, changes in the Earth's orbital shape, changes in the ocean-atmosphere connection. The only way to know is to read the older pages. Drilling projects have surveyed sites where the flow is slow, the snowfall is low, and the ice may be old enough to preserve the history intact. Cores from such sites will not just add years, they will change the questions. The ice holds records of fire and floods on smaller scales as well. Long continuous cores record the sulfur haze from volcanic winters and the traces of soot and nitrates from changing biomass burning as forests wax and wane on the continents. They capture the appearance of lead and other pollutants during the industrial era, and their decline as cleaner fuels and better laws took hold. They reveal modern patterns of sea salt that march with the expansion and retreat of sea ice. The dance that governs the life of krill and penguins. In West Antarctica, high-resolution calls from the watershed between the Ross and Ron Bays show sharp shifts in snowfall that correlate with changes in wind belts and ocean fronts. Ice along the Amundsen and Bellingshausen seas has taught glaciologists how warm deep water can intrude beneath the floating shelves, thinning them from below and accelerating the glaciers that feed them. The archive is not only history, it is also a lens for the present. Beneath the East Antarctic ice, another story waits in the gravity field. In 2006, researchers studying satellite data described a circular anomaly beneath Wilkes Land that stretches more than $400, text $10. One interpretation is a buried impact structure from a colossal asteroid that struck far back in the Permian period, a body large enough to leave a scar larger than the famous crater in the Yucatan. If this interpretation is correct, the impact may have disrupted the climate and life near the time of the Great Extinction that marked the end of the Permian period. The idea is bold and remains contested. The data is circumstantial, and the ice denies easy access to the rocks that could settle the matter. Nevertheless, the possibility reminds us that Antarctica holds not one secret. It archives not only air and dust, but the deepest violence of planetary history. The most important lesson from this time capsule is simple and sober. Earth's climate has always changed, and in the past, those changes were driven by slow celestial mechanics and amplified by feedbacks in the ice, oceans, and greenhouse gases. Ice sheets grew and contracted. Sea level fell and rose by many tens of meters. The data proves these things with calm numbers. They also show that the current rise in greenhouse gases is not part of this ancient range. It is a new mark, driven by human use of coal, oil, and gas, and by deforestation. The curves have flown off the page that the ice knows. In West Antarctica, glaciers like Foots and Pine Island are responding to warming oceans with a retreat that could lift them from the bed and raise sea level around distant cities. Past layers tell how fast ice can move when thresholds are crossed. These stories are warnings written in water. Antarctica does not speak in headlines. It speaks in layers and cautious counts. Every summer, the camp on the dome becomes a quiet factory of knowledge. Drillers lower cable into the cold dark and hear soft pops as ancient bubbles burst under pressure. In the core barrel, a scientist lays a fresh meter of ice on the bench and logs its crystalline structure grain by grain. Others cut samples for gas, for dust, for trace metals, for isotopes, for tiny shards of volcanic glass. In a workshop on the other side of the world, a mass spectrometer sips a measured gulp from a vial and returns a number with many digits and a small uncertainty. From linked routines like these, the picture of deep time becomes clear. The white continent holds the evidence with patience. We must be patient enough to read it right. Myths of ancient cartography. Let us start in a dim reading room with a map lying flat beneath glass. Ink shorelines curve like a memory. At the bottom of the page, a great land waits where few have sailed. For centuries, the southern continent existed as a supposition and a hope. In the 20th century, it attracted a different kind of attention. Writers and researchers began to wonder if there might be a trace of a very old culture beneath the ice. The idea is bold. It is also a test of how we weigh evidence against desire. At the heart of the modern assertion lie two documents. The first is a map drawn in 1513 by the Ottoman Admiral Piri Reis. It stitched together older sources from Portuguese pilots and possibly the voyages of Columbus to present a new kind of Atlantic. Along the bottom edge trails a jagged shore that some readers have called ice-free Antarctica. Most historians see a different story. The shapes conform to South America, drawn to long and stretched into the high latitudes. The map is a compilation, created at a time when longitude was an art, not a science. It is remarkable for its ambition. It is less remarkable as an accurate record of the far south. The second document is a heart-shaped world map published by Ernst Fine in 1531. It shows a vast southern land wrapped around the pole and inscribed with rivers and harbors. Later maps by Mercator and the Dieppe school continued this habit. More than a century later, the French geographer Philippe Boich published a speculative map that divided Antarctica into two large islands with an internal sea. Modern radar and seismic surveys have revealed subglacial basins and mountain ranges beneath the ice that do indeed give the continent a complex spine. The match seems eerie at first glance. Yet, Boich had no secret surveys. He was following a chain of reasoning common in his time. Many geographers believed in an open polar sea and imagined how rivers and channels might be situated around the pole. The resemblance to what we have since found in broad outline is a coincidence born of a very general supposition. In the 1960s, Charles Hapgood published a thesis that became a cornerstone for Antarctic Atlantis. He argued that the outer shell of the Earth could slip as a whole over the interior when ice accumulated off-center and threw the planet out of balance. By this scheme, the poles suddenly move across the surface. An advanced culture might have mapped an ice-free Antarctica and then been destroyed. When the crust shifted, Hapgood pointed to the Piri Reis map and other early charts as hints of a forgotten knowledge. Albert Einstein wrote a preface, praising the curiosity and scope of his questions. The core assertion did not stand up to testing. Geophysics and plate tectonics have shown that continents move slowly on convection cells in the mantle. Paleomagnetism, seafloor magnetic stripes, and the match of fossils across now separated lands create a precise record of this movement. True polar wander does occur over very long spans of time as the planet's mass rebalances. There is no evidence that the crust can slip rapidly, and no mechanism to support a sudden shift within the period of human cultures. Not all signals come from above. The ice itself flows, and where it passes over bedrock, it can entrain tiny crystals and traces of metals that hint at the continent below. Radar, towed on sledges and aircraft, penetrates the ice sheet and returns an echo of the buried land. A hidden world has emerged from these surveys. The Gamburtsev Mountains, a jagged range the size of the Alps, sit buried beneath the center of East Antarctica. Vast valleys and plateaus, carved long before the ice came, are now locked in darkness. Beneath the ice lie lakes that may not have seen daylight for a million years. Lake Vostok is the largest, a body of freshwater larger than many of the world's known lakes, sealed under nearly $4,000 Texan dollar of ice. The water is under pressure and barely moves, warmed by the Earth's heat and insulated by the ice above. Near Vostok, sensors detected a strong magnetic anomaly. The probable answer is unusual geology. Two others. It seemed a key to something stranger. In science, the richest story is almost always the one that can be tested. Teams have drilled shallower subglacial lakes in the west with sterile instruments and found life. At Lake Willens, they raised water and mud teeming with microbes, feeding on rock and breathing chemistry in total darkness. Life can thrive in isolation without sunlight, provided there is energy and time. The ice sheet also records the history of our star. Solar storms shower the Earth with particles that collide with the upper atmosphere and create rare isotopes, such as beryllium $10, Texby $10, and chlorine $36. Texcal $3.6. These show up as faint peaks in the snow records during periods of high solar activity, or when the Earth's magnetic shield weakens. Thus, the ice is a celestial diary. It also carries a whisper of the cosmos. Each year, micrometeorites dust the planet. In Antarctica, many of these tiny visitors become locked in the ice. And then, where the wind scours the surface in blue ice fields, they weather out and collect. This is why search teams on snowmobiles can find meteorites by the hundreds along the flanks of the transantarctic mountains. Among them are rocks from Mars and the Moon, ancient fragments that fell long ago and were preserved by the cold and wind. In the Allen Hills, a team in the 1980s found a Martian rock with mineral features that prompted a famous debate over possible fossilized life. The debate sharpened the methods, which is the best outcome such debates can have, and the blue ice still yields new rocks every summer. The Atlantis myth and limitations. Sea level. The sea level history of the last 20,000 years does not favor this claim about Antarctic Atlantis. At the peak of the last glacial period, global sea level was more than $100 Texan dollar lower. The ice in Antarctica spread further, and the climate around the pole was harsher than today. An island as large as Plato described could not have been hidden beneath a mild sky near the polar circle during that period. History continues to inspire work in archaeology. The map of the Atlantic Basin remains crowded with real candidates for lost coastal sites on the shelves, now submerged by post-glacial seas. These searches do not point south. Proponents of a very old culture often turn to mysterious images in the ice to support their position. Satellite photographs sometimes show geometric shadows along a ridge or slope that appear too regular to be natural. Careful surveys on the ground and from the air almost always identify these shapes as familiar geology. Pyramidal mountains arise where several glaciers carve the same peak and leave a cirque. Linear ridges can be sastrugi, carved by the wind. Rectangles are the trace of a tabular iceberg cut with planes broken at right angles. In a world of glare and shadow, the mind completes the rest. None of this deprives the continent of mystery. It merely insists that the mystery must be earned by patient labor. The question of memory remains. Could knowledge of the far south have survived in older cultures and been passed down through secret channels to the cartographers of Europe? This is possible on a small scale. Information moves along trade routes, like a scent on the wind. Polynesian navigators explored deep into the South Pacific and may have seen pack ice or great icebergs on voyages south of New Zealand. They stored their knowledge in songs and star paths, not on parchment. Islamic cosmographers collected reports from pilots in the Indian Ocean and the Red Sea, and wrote encyclopedias of the world that acknowledged uncertainty at the far south. Medieval European portolan charts excelled at describing the coasts and currents well known to merchants and remained silent about the unknown. A whisper can cross oceans. A detailed survey of a hidden civilization cannot. The kinds of knowledge we see on early modern maps are the kinds that sailors bring home from the limits of their supplies and their ships. The most eloquent argument for or against a lost Antarctic civilization is the absence of physical remains where we have learned to look. Archaeology on land depends on sites that are frozen, dried, or rapidly buried. The interior of Antarctica is a vast eroding surface of ice that flows to the sea and grinds everything in its path. Coastal refuges that have been ice-free for extended periods are few and small. At these capes, scientific teams have worked for decades. They have found sealers' camps and the remnants of whaling huts. They have found penguin cemeteries and peat moss banks that record the climate of the last millennia. They have not found stone cities, or metal artifacts, or pottery from a deep human past. A fair report must leave room for surprise. The continent holds subglacial lakes that no human eye has ever seen, and mountain ranges that have never been climbed. Caves warmed by volcanoes on Ross Island harbor traces of plants and environments that are warmer than the air above. There are places on the continental shelf where sediments may archive river plumes from a warmer epoch and where future drills may find what we do not expect. To maintain an open mind is not to suspend judgment. It is to set a standard. Claims that change history must meet the weight of evidence that history requires. The geometry of ice and the failure of hypotheses, what remains when the fog of legend disperses, is not insignificant. Antarctica changes our view of human time, not because it hides palaces, but because it preserves an older and vaster history. It shows that continents wander. It shows that climate swings can redraw the face of the Earth. It shows that life adapts and survives at the edge of what seems possible. The ancient world does not need a southern Atlantis to be magnificent. It needs a clear report on how the sea, wind, and stone change the stage on which humans act. Let's start with a satellite pass over the White Country. Shadows lengthen along the mountain ridge and resolve into perfect edges that seem to need to be natural. The image circles the world, and by nightfall, a new assertion blossoms. Buried beneath the ice is a pyramid or an entrance to a hidden world, or a spaceship frozen in place from a forgotten era. Antarctica lends itself to such stories. It is vast, it is remote, it keeps its silence, but the closer you look, the more the familiar laws of geology and weather come into view, and they tell a more resilient story. Take the famous photographs of pyramids. In the Ellsworth Mountains and along other ridges, glacial erosion cuts hard rock from several sides at once. Where 3 or more cirques carve into a peak, they leave behind a horn with clear ridgelines and triangular faces. Matterhorns exist in many latitudes because ice carves similarly wherever it flows. The symmetry can be striking to the untrained eye, especially when the low sun casts a blue shadow on a white slope. The clean geometry tempts the imagination. Nevertheless, the field parties who climb these peaks report finding what they always find in high latitudes: wind-eroded granite, lichen crusts, cornices ready to collapse, nothing laid down by human hands. Another example is the sea. In 2018, a research plane photographed a rectangular iceberg drifting off the Larsen Bay. It looked as if a surveyor had drawn the edges with a ruler. The explanation is ordinary physics. Ice shelves break along planes of weakness, and those planes often intersect at right angles. A tabular iceberg cut from a shelf can have a long straight face and a right angle, just as a brick shows a clean edge when it splits along a pure line. With time and wave action, even the most precise angle will round and crumble. The camera caught the newborn iceberg before the weather had time to smooth it. Most of the myths coalesce around Lake Vostok, the largest body of water beneath the ice sheet. Radar and seismic surveys in the 20th century detected the lake beneath nearly 4,000 meters of ice, a dark world the size of a small country. Gravitational and magnetic maps show anomalies in the crust near the lake. The words anomaly and Antarctica make a potent cocktail. A magnetic anomaly is a deviation from the average field. It can arise from iron-rich rocks, from deep faults, or from ancient volcanic bodies. The most likely explanation for the Vostok signal is geology that predates the ice sheet by many millions of years, when Russian and international teams have drilled other, smaller subglacial lakes with clean systems. They have discovered microbes that live on minerals and chemical energy in the cold. Life in the dark does not require guests from the stars. It requires water, nutrients, and time. The legends also circle Operation High Jump. A patrol plane crashed in bad weather, and 3 men died. The season ended earlier than planned, as the austral summer was winding down. These facts spawned a story that the task force fought an unknown enemy over the ice. Documentary records show a large training and mapping exercise with hard lessons in polar logistics, and a commander who later warned that in the age of long-range aircraft, the shortest routes between continents pass over the poles. A sober strategic insight became a coded message about air threats from the south in some retellings. The distance between those two readings is the distance between caution and fantasy. One of the oldest Antarctic myths is the Hollow Earth. In this tale, the planet opens up at the poles into caverns large enough to shelter lost worlds. The idea is older than flight and newer than folklore. Photographs from polar orbiting spacecraft that show a dark oval over the pole in winter have been used as proof. In reality, these voids are places where satellites have not collected data, or where the long high latitude night created a blind spot in early imagery. The Antarctic Treaty does not hide entrances. It publishes inspection reports and invites observers to any station at any time. A continent governed by many nations and visited by thousands of scientists and crew each summer is not a likely custodian of a secret door. Rumors of no-fly zones also recur. There are flight safety rules on steep mountains and along ice shelves, where wind shear eats wings. And there are protected areas for wildlife, where low flights are restricted during breeding season. There are rules for the preservation of historical huts. There is no blanket ban over an entire sector for mysterious reasons. Pilots in Antarctica share weather and runway condition information by radio, because survival depends on it. In this environment, transparency is not a slogan. It is a custom that keeps people alive. Meteorites, mysteries, and a reminder meteorites pull another thread of rumor. The Transantarctic mountains hold blue ice fields where the wind scours away snow and brings old ice to the surface. Rocks that fell long ago and sunk into the snow move upward with the flow and collect along the ridges like pieces swept to one side of a board. Snowmobile teams scour these areas each summer and recover hundreds of meteorites. A few arrive from Mars and the Moon. Their chemical makeup and trapped gases match what rovers and orbiters have measured on those worlds. One rock from the Allen Hills carried structures that some interpreted as microfossils. The claim did not stand in its original form. The debate sharpened methods and taught a generation how to separate biological patterns from mineral textures. On the ice, even arguments become data. The continent does contain places that seem unnatural. The McMurdo dry valleys present a Martian landscape of salt crusts and cliffs, where snow evaporates into the air without melting. A rusty cascade called Blood Falls pours from the terminus of a glacier, when iron-rich brine meets oxygen and turns red beneath the Ross ice shelf. A camera recently observed fish drifting in water that never sees the sun. At the South Pole, scientists listen for the faint pops of neutrinos in a cubic kilometer of clear ice, with an installation called IceCube. These facts feed the imagination because they are strange and true. They do not need rescue by fantasy. Some regions are closed for good reasons that have nothing to do with hidden machinery. Specially protected areas include moss banks that record centuries of climate. There are fragile penguin colonies where foot traffic would destroy nests. There are zones with historical artifacts that could be ruined by a careless hand. Permits and fences exist because a footprint on soft ground can persist in this climate for an entire human lifetime. Researchers plan their seasons around these rules because the archive of the South is finite and precious. The tension of territorial claims still exists. The continent that could have provoked conflict became a school of patience. The International Geophysical Year taught that shared hardship can make neighbors out of rivals. The treaty cemented that lesson into law and kept the truce persuasive through inspection and open exchange of records. The environmental protocol shifted the moral center from conquest to care. In Antarctica, it punishes pretense. The weather does not negotiate. The ice does not acknowledge a flag. A plan that ignores either will fail, no matter who signs the permissions. The longer arc tells a simple story. The continent that could have provoked conflict became a school of patience. The International Geophysical Year taught that shared hardship can make neighbors out of rivals. The treaty cemented that lesson into law and kept the truce persuasive through inspection and open exchange of records. The environmental protocol shifted the moral center from conquest to care. In the process, Antarctica has revealed its deeper value. It is a climate archive and an ocean valve, a clean laboratory for South Pole astronomy, a cradle for penguins and seals, and a testing ground for how nations can manage a common good. The genesis of myth, truth versus desire. The resilience of Antarctic myths speaks as much about us as it does about the ice. We are drawn to patterns. We prefer intention to accident. We bring stories to places that are hard to reach and harder to understand. Yet Antarctica rewards a different posture. It asks for patience and method. It returns with discoveries that are quieter than legends and far more significant. A layer in a core that marks a lost atmosphere. A fossilized tree that grew in summer lights near the polar circle under a greenhouse sky. A microbial community that thrives beneath a kilometer of ice. A wave that shows how a shelf is reacting to an ocean that is a little warmer this year than last. In a place where the air stings and the compass fails, the best guide remains evidence. The continent holds secrets, but they are the kind that instruments can coax out and minds can verify. To stand on a ridge and watch a blue shadow cut a pyramid across the slope is to feel the pull of a tale that is older than science. To climb that ridge and read the scratches in the stone and the texture of the ice is to learn the older story that rock and water tell together. Both experiences are part of why people return. One feeds wonder, the other builds knowledge. In Antarctica, there is room for both, provided we know which is which. The camera opens on a scroll of names and flags, a living roll call of nations that have vowed to preserve an entire continent for peace and science. Today, the Antarctic Treaty parties number 58, 29 of which hold consultative status, a club of countries that actively shape the rules by consensus. A new flag joined the list in May 2024 when Saudi Arabia acceded. A reminder that the governance of Antarctica is not frozen in time. Consensus is the quiet heartbeat of Antarctic diplomacy. At the annual Antarctic Treaty Consultative Meeting ATC, measures are adopted only when every consultative party agrees. There is no veto to be raised, only a commitment to listen longer and draft better until the room exhales together. This design, simple on paper, has preserved continental peace for over 6 decades, allowing science to lead. Underpinning the treaty is its environmental conscience, the Madrid Protocol. It made the continent a natural reserve devoted to peace and science, and prohibits mineral resource activities other than research. That prohibition is not set to quietly expire. Article 7 is explicit, and while Article 25 permits parties to convene a general review conference from 2048, the materials of the protocol itself and the Australian Antarctic Division explain that talk of an automatic sunset after 50 years is a misconception. Protection is the default, and any change would require a very high political bar. Geopolitics and scientific logistics on the ice. The rules have a geography you can walk on. There are dozens of year-round and seasonal stations scattered along the coast and inland, managed by national programs that coordinate fuel, food, weather, search and rescue, and precise science with military accuracy. Even when a military presence serves only peaceful logistics, the heads of these programs maintain a common catalogue of facilities and vessels, so that a broken traverse in Queen Maud Land can raise a neighbour at Troll, Noumea, or Princess Elizabeth, and a medical evacuation can plot a route of planes and blue ice runways across borders that do not exist here. New construction can signal new intentions. China's Kinling Station opened on Inexpressible Island in Terra Nova Bay in February 2024, gives Beijing a year-round foothold in the Ross Sea region, complementing Great Wall, Zhongshan, Kunlun, and Taishan. Analysts note that the station's position and capacity expand both scientific reach and political presence. Chinese sources also emphasize a drive for cleaner local energy, with the integration of wind, solar, and hydrogen. Elsewhere, the question is not always what to build, but whether to build at all. Australia considered constructing a paved runway near Davis Station, but after extensive environmental and economic assessment, decided in 2021 not to proceed. The seas of the Antarctic are regulated by a sister body, the Commission for the Conservation of Antarctic Marine Living Resources, CCAMLR, which manages fisheries and seeks to balance food webs susceptible to warming and melting. The Commission established a marine protected area in the Ross Sea region. In 2016, a landmark decision. Yet, proposals for large new protected areas in the Weddell Sea and East Antarctica have stalled. Repeat. ever since, because CCAML requires unanimous consent. Reports for 2024 and 2025 describe how difficult it is to reach this consensus, as member states contest where and how to limit catches and areas. Krill is a small creature that reveals a large dilemma. CCAMLR sets a catch limit of $5.61 million tons across the entire Scotia Sea, but imposes a trigger level of $620 tons, until a finer distribution is agreed upon, a precaution against concentrated pressure in penguin unwell feeding grounds. In 2025, the fishery hit this $620,000 ton ceiling for the first time, leading to an unprecedented early closure. The number looks modest next to the total biomass, but the point of the trigger is not volume. It is about distribution in space and time. Tourism has emerged as a second test. The International Association of Antarctica Tour Operators (IATO) reported $118,481 visitors in the 20,242,025 season. This is, nonetheless, an order of magnitude higher than a generation ago. IATO's report to the 2025 consultative meeting reads like a logbook of an industry trying to discipline itself. With more people comes more biosecurity. Highly pathogenic avian influenza (HPO) reached Antarctica in the austral summer of 20,230,2024. First on the sub-Antarctic islands, then on the continent itself. Researchers documented positive cases in skunks and penguins, and the scientific community, with IATO and CONAP, responded by tightening protocols for cleaning gear, distancing from wildlife, and rapid reporting. Shared risk is quickly becoming shared practice. Shipping is regulated by an outer ring of global maritime rules adapted to polar dangers. The IMO Polar Code sets requirements for ship design, training, and operation in polar waters. Antarctic waters have gone further on pollution risk, implementing a ban on the use and carriage of heavy fuel oil since 2011. The result is a higher baseline of safety and a lower baseline of spill risk, even as more vessels approach the peninsula each summer. Technology and trust, real-time science. Antarctica's transparency is not rhetorical. It is written into Article 7 of the treaty. Any consultative party can designate observers who can inspect stations, vessels, and equipment anywhere south of $60 circ south latitude. Reports go into a public database, and the culture of inspection has evolved over decades. It is a quiet deterrent against unscientific activity and a real incentive to keep fuel tanks tidy, waste drums sealed, and science programs documented. The inspection clause takes up only a few sentences. It has likely done more for compliance than any patrol. Finally, science itself shapes the geopolitics here. The international cooperation on the Thwaites Glacier is not a flag, yet. The British and American teams hot water drilling boreholes and deploying the Icefin robot beneath the collapsing ice shelf are doing work that informs coastal planning from Miami to Mumbai. Project updates emphasize that Thwaites will retreat further and faster this century. Even if sudden collapse is unlikely soon, a political message disguised as glaciology. The story of modern Antarctica is one of a system that still mostly works, because the people inside it keep doing the slow, public things that make trust possible. They publish numbers, file inspection reports, argue about commas, and call a colleague when the wind picks up. It is not a perfect system. It is a rare system. Let's begin at the edge of a floating ice shelf, where the sea is black and quiet, and the ice above is a cathedral of blue light. A small robot slips into the water and disappears beneath a $200 thick ceiling. It carries cameras, sonar, and instruments that sample heat and salt. The robot is part of a quiet revolution. We are learning to see places that once defied all sight. Beneath the ice shelves, warm deep water intrudes inland in narrow layers. It melts the ice from below and carves out channels the length of cities. Autonomous vehicles are now mapping these tunnels and measuring how fast the shelf is thinning. The knowledge is specific and immediate. When a shelf's grounding line retreats, the glaciers that feed it often accelerate. The lesson is written in numbers, but the stakes are coastal and human. The next frontier stands on a wind-whipped dome in East Antarctica, where the sky is so dry that the stars seem close enough to touch. Here, crews lower a drill into ancient ice. The goal is a core older than 1 million years. In the cores we already have, air bubbles record 8 long swings between cold and warm epochs. A deeper core will cross a shift when the rhythm of the ice age changed. It's a mystery that underpins climatology. To find this ice requires patience and geometry. It needs a summit where snowfall is slow, flow is gentle, and the layers are not crumpled. Drilling is a craft we've honed for half a century. Cables vibrate in the cold. Core barrels need to be watched for hairline fractures that steal the air. Every meter is logged, cut, sealed, and shipped out in a ballet that never gets easier. The reward is a new page in Earth's climate history. Beneath the ice lies a landscape the size of a continent, because it is one. Radar and gravity surveys have revealed an inland ridge that rivals the Alps, valleys that hold ancient sediments, and lakes sealed from the sky, perhaps for 1 million years. Over 400 subglacial lakes have been confirmed. In the west, clean drilling of a shallow lake revealed a living community that feeds on rock and chemical energy in total darkness. The next steps will be bolder. Engineers are designing probes that can melt a column of ice, release a swimmer into a lake, and return without contamination. Doing this safely is as hard as any mission in exploration. The prize is a direct look at a biosphere sustained without sunlight. It's a lesson for understanding where life might persist on icy moons far from our sun. The ice surface carries its own instruments. Satellites shoot lasers at the ice sheet and measure the return time to 1/1000th of a second. They send radar pulses through the surface and watch the scatter of energy to map the snow and roughness. They weigh the continent by tracking small changes in gravity as ice is lost to the ocean and snow falls inland. When these lines of evidence coincide, we can watch the ice mass change year by year and in places, month by month. New missions resolve the Southern Ocean vortex with unprecedented detail and monitor the eddies that carry heat to the shelf edge. Machine learning sifts millions of images for new rifts, surface lakes, and iceberg calving fronts. The continent that once hid behind storms is now updated on screens in real time. The ecosystem laboratory birth of a new sea on the coast. The future will arrive as a natural experiment. When a large part of an ice shelf caps, the ocean that lay beneath the ice sees light for the first time in centuries. Scientists rush to deploy moorings and nets to record the birth of a new ecosystem. Algae bloom in the bright water. Krill gather, and fish arrive. Penguins check out the new edge. Within a decade, the community may stabilize or be reset by the next calving. Repeat studies of these windows tell us how fast life assembles after ice retreat, and what conditions foster resilience. Simultaneously, krill fishery monitoring continues to move to finer scales, so that catch limits match how predators actually feed, not just a gross total across the entire basin. The link between ice, food, and policy is precise and getting tighter. Astronomy and physics have turned the high plateau into a kind of terrestrial space observatory. At the South Pole, a grid of sensors buried in the clear ice listens for the faint light produced when particles from distant galaxies pass through the planet. A neutrino can cross a wall of lead the thickness of a mountain and not notice. Yet, on rare occasions, it yields a flash in the dark. Each flash carries information about violent events that happen far away in time and space. Nearby, telescopes stare at the ancient microwave glow left over from the universe's first light and look for subtle swirls in its polarization that would hint at how space itself expanded in the first moment. The air at the pole is dry and calm. It gives these instruments a stability that mountaintops cannot. New installations and colder detectors will sharpen their gaze. Meteorites write a different stellar history on the ice. Blue ice fields along the transantarctic mountains act like slow conveyor belts. Rocks from space that fell long ago are concentrated at the surface where the wind removes the snow. Each summer, Field teams spread out in lines and collect hundreds of stones. Some are ancient pieces of Mars's crust. Some are fragments of the moon. Others come from asteroids that formed when the solar system was young, cut and polished in labs. These stones hold keys to our system's earliest chemistry and to the water and organics that later fueled life. The ice is a partner in this work. It preserves what would break down elsewhere. The stations themselves are changing. Engineers are turning them into cleaner islands on the White Sea. Solar panels climb the walls to drink the 24-hour summer light. Small wind turbines spin in the steady coastal air. Microgrids weave batteries, generators, and intermittent renewables into a system that burns less fuel. Waste is sorted and shipped north. Old landfills are dug up and removed. Some stations use hydrogen as a buffer to store energy in the cold. Others are testing new insulation and new building shapes that shed drifting snow and keep the heat where it belongs. The purpose is practical and moral. Life support in this climate is hard-won, and every liter of fuel saved in a drum is a quieter footprint. Beneath the ice and rock waits another set of questions. Seismic lines and magnetic maps suggest deep sedimentary basins that may hold records of rivers that once flowed across a greener Antarctica. Marine drills on the continental shelf retrieve cores that record when grounded ice first advanced and when it retreated. These cores hold shells and microfossils that allow us to date the steps in this dance. With these dates, we can test models that predict how the ice will respond to warming oceans and changing winds. Where models match the geologic past, confidence grows. Where they don't, the models change. It is a discipline that allows for uncertainty and then works to shrink it. In the coming years, more eyes will turn south. New radar satellites will measure the velocity of glaciers at the scale of small towns. New laser altimeters will track the growth of surface lakes that form on the shelves each summer and can induce fractures when they drain. Instrument arrays will be placed on the seabed at the shelf edge and count the pulses of warm water that try to intrude beneath the ice. Balloons will drift with the polar vortex and sample the air over the ice cap into the long darkness. Every line of data will tie the continent's story more closely to the planet's. The persistence of myth and the truth of the ice. The persistence of Antarctic myths speaks as much about us as about the ice. We are drawn to patterns. We prefer intention to randomness. We bring stories to places that are hard to reach and harder to understand. Yet, Antarctica rewards a different stance. It asks for patience and method. It gives back with discoveries that are quieter than legends and far more significant. A layer in a core that marks a lost atmosphere. A fossilized tree that grew in summer light near the polar circle under a greenhouse sky. A microbial community that thrives beneath a kilometer of ice. A wave that shows how a shelf is responding to an ocean that is a little warmer this year than last. In a place where the air stings and the compass fails, evidence remains the best guide. The continent keeps secrets, but they are the kind that instruments can tease out and minds can test. To stand on a ridge and watch a blue shadow cut a pyramid across a slope is to feel the pull of a tale that is older than science. To climb that ridge and read the scratches in the rock and the texture of the ice is to learn an older tale that rock and water tell together. Both experiences are part of why people return. One feeds wonder, the other builds knowledge. There is room for both in Antarctica, provided we know which is which. It begins with a hand brushing snow from a dark rock on a ridge that overlooks a white plain with no end. The rock is not ordinary. It holds the impression of a leaf with veins as fine as thread. It is Glossopteris, a seed fern that spread across the southern supercontinent in the Permian period over $250 million years ago. In the end, Antarctica reshapes our view of human time, not because it hides palaces, but because it preserves an older and vaster history. It shows that continents wander. It shows that climate swings can redraw the face of the earth. It shows that life adapts and survives at the edge of what seems possible. The ancient world does not need a southern Atlantis to be magnificent. It needs a clear account of how the sea and the wind and the rock change the stage, on which humans act. The camera returns to the black water beneath the ice shelf. The robot's lights dim to a pair of distant stars. Above, the ice groans with the slow speech of a living slab. Beyond the horizon, a drill turns, and a telescope listens. The continent is still teaching. We are finally learning to ask better questions. Sleep well, my listener. May your rest be as peaceful and clear as the ice of Antarctica.